Hey there, have you ever wondered what makes the world go round? Well, the answer lies in a fundamental force that powers everything in our universe: energy. Energy is that invisible yet indispensable force that makes things happen, from the beating of our hearts to the rotation of the Earth. It's what allows birds to fly, cars to move, and stars to shine. Energy, however, isn't a one-size-fits-all sort of thing. It comes in various forms, each with its own unique characteristics and functions. Today we're going to focus on two of these forms: kinetic and potential energy. These might sound like big complicated words, but by the end of this video, you'll understand them as easily as you understand the concept of day and night. So, buckle up as we delve into the fascinating world of kinetic and potential energy. Exciting discoveries await us. First off, let's tackle kinetic energy. Sounds fancy, right? But it's actually a pretty straightforward concept. Simply put, kinetic energy is the energy of motion. It's the energy that an object has because it's moving. Imagine you're watching a car zoom down a highway, or a soccer ball rolling across a field, or even a person sprinting for the finish line in a marathon. All of these things are moving, and that movement is powered by kinetic energy. Now, it's important to understand that the amount of kinetic energy an object has depends on two factors: its mass and its speed. Think about that car we mentioned earlier. If it's a big heavy truck barreling down the road at a high speed, it's going to have a lot more kinetic energy than a small, light bicycle moving at the same speed. On the flip side, consider that running person. Even if they're not particularly large or heavy, the faster they run, the more kinetic energy they're generating. So, while the term kinetic energy might sound like something out of a science fiction movie, it's actually a fundamental part of our everyday lives. It's the energy that powers movement, from the smallest particles to the largest objects in the universe. So remember, if it's moving, it's exhibiting kinetic energy. Now let's switch gears and talk about potential energy. Imagine you're holding a rubber band, pulling it back as far as it will go. You can feel the tension, right? That's potential energy. It's the energy stored within an object because of its position or condition. Think of it like this: a rock perched precariously at the top of a hill. It's still, it's quiet, but there's an undeniable sense of anticipation. That's because the rock is brimming with potential energy. It has the capacity to tumble down the hill at any moment, transforming that potential energy into kinetic energy. Or let's consider water stored behind a dam. It's a peaceful scene, but there's power there too. That water holds a massive amount of potential energy. If the dam were to break, the water would rush out, converting its potential energy into kinetic energy, cascading down with incredible force. In each of these examples, the potential energy is a kind of stored promise of action. It's energy that's waiting, poised, ready to spring into action when conditions change. It's the energy of what could be, the energy of possibilities. Potential energy might not be as visible or as dynamic as kinetic energy, but it's just as important. It's the quiet before the storm, the deep breath before the plunge. So, potential energy is all about what could happen, the energy waiting to be unleashed. You might be wondering, how do kinetic and potential energy relate to each other? Well, it's quite fascinating. These two forms of energy often convert into each other, creating a dance of transformation that fuels the very movement of our universe. So let's visualize this concept with a simple example. Imagine a pendulum swinging back and forth. At the highest point of its swing, the pendulum is at rest, momentarily frozen in time. Here it has maximum potential energy because it's as high as it can get. Now, potential energy is all about position or height, remember. So it's at its peak here, literally and figuratively. But then, the pendulum starts to swing back down. As it does, that potential energy begins to transform. It converts into kinetic energy, the energy of motion. The pendulum speeds up, reaching its maximum speed at the lowest point of its swing. Here, kinetic energy is at its maximum because the pendulum is moving as fast as it can. But the dance doesn't stop there. As the pendulum swings up again, that kinetic energy starts to convert back into potential energy. The pendulum slows down, eventually coming to a stop before it begins its descent once more. And so the cycle continues, back and forth, potential to kinetic and kinetic to potential. Another way to visualize this is by thinking about a roller coaster ride. At the top of the highest peak, the coaster car is full of potential energy. Then, as it races down the slope, that potential energy converts into kinetic energy. And as it climbs up the next peak, that kinetic energy changes back into potential energy again. So, in a nutshell, Kinetic and potential energy are two sides of the same coin, constantly transforming back and forth. It's a beautiful dance of energy conversion that happens all around us, powering the very movements of life. Whether it's a falling apple, a rolling wheel, or the beating of our hearts, this dance between kinetic and potential energy is an integral part of the universe's rhythm. Well, that's a wrap on kinetic and potential energy. We've journeyed through the fascinating world of these two energy forms, diving deep into the essence of what makes them tick. In our exploration, we've discovered that kinetic energy, the energy of motion, is everywhere around us, from the falling droplets of rain to the speeding cars on the highway. Then, we transition to potential energy, the stored energy that has the potential to do work. We've seen how it lies in waiting in a stretched rubber band or a rock perched on a hillside. We've also delved into the beautiful dance between these two energies, the constant conversion from one form to the other, potential to kinetic, and back again. It's a cycle that powers our world, from the smallest atom to the largest galaxy. But here's something to ponder. Can you think of a moment in your day where you directly experienced the conversion of potential energy to kinetic energy? Share your thoughts in the comments below.